Okay, so welcome back again, and this is Chipmaster, and in this video series I will be repairing a HP, and it's written on it powering on and off, as you can see. Right, so it says powers on and off. So that's the problem that they say it's having. Right, so they gave it to me to repair, and it's already disassembled. As you can see, the screws at the back here, so it is already disassembled halfway. So I will now head over to the overhead camera. Okay, so as you can see, it's already disassembled, so I don't have to remove anything, any screws. I didn't actually test it before. So I'm going to power the unit now. I'll take a look at the DC power supply. Alright, so let me just adjust the voltage some more here. So I'm plugging in the adapter now. Right, so I get 20 milliamp there, and press the switch, and I get 60 milliamp. 60 milliamp, and that's it. So let me see if it turns off back after. Alright, so it's on. Alright. I'm just waiting to see if it's gonna shut off. Okay, so it powers off immediately. Yes, it powers off. Alright, so as you can see there, it powers off. So I'm gonna head to the multimeter now. I'm gonna check the resistances. Alright, so first I'm gonna check all coils. Alright, so I'm gonna check all the coils, right, to make sure there is any short circuit or any abnormal reading on any of the coils. So this is the ram supply coil, I believe. I get 116 there. I think it's too bright. Alright, next we have 5 volts. Alright, I work on these laptops a lot, so I know exactly where the voltages are produced. This is 3.3 volts. Alright, 349. This is a battery power supply, sorry. 503. This is VCC SA. Oh, this is VCC IO. And this is CPU core. And this is the graphics, integrated graphics. That's also good. I need to find 1.8 volts. 1.8 volts, it should be this here, 1.8. All right. This should be VPP 2.5 volts for the RAM, and that's good. So there's no short. Okay, so plugging in back the charger now. All right, so I press the switch. I'm going to see if the CPU releases its ACPI configuration signals. No RAM supply is there. No RAM supply. I get 5 volts. Oh, it shuts off back. Let's try again. Okay, I got 5 volts. I have 3.3 volts. And this is battery charging voltage. Alright, so I'm pressing again. Let me see if I get 3.3 volts for the BIOS. Yes, the BIOS chip gets 3.3 volts power supply. So the RAM voltages are not generated. Alright, so I'm checking here for 1.8 volts. 1.8 volts is there. Alright, let me check if I get, so no VPP 2.5 volts. So most likely the CPU is not releasing the ACPI configuration signals. So this one is gonna be a bit tricky, I believe. So I'm not getting 1.2 volts for the RAM. No VPP voltage, which is controlled by SLPS4, which is coming from the CPU. Right, 1.8 volts is there. Alright, 5 volts is there, 3.3 volts is there, but no RAM supply, and no RAM VPP voltage 2.5 volts. So I will need to check now the working conditions of the CPU, such as VCC RTC, RTC reset, SRTC reset, right, VCC DSW, right, VCC D power OK, DSW power OK, sorry, and RSM reset and the power button. So I have to make sure that the power button is actually coming from the EC, which is going to be sent to the CPU, and so forth. So first let me check the RTC crystal. So the RTC crystal is here, and there's no burn or any explosions on the board. There's no explosion on the board that you can see. The board is clean, no liquid intake, no mildew, no corrosion. Alright, so I'm just checking and inspecting on the board, and there's nothing that is obvious, such as a burn or a liquid intake. Alright, so let me check the RTC clock crystal. Alright, so if I get in voltage, then the crystal is working. So I'm getting 0.3 on one side of the crystal, and on the other side I get 0.2728, which is right. Remember, in the last video on the desktop motherboard repairing, the voltage on each side of the crystal should be different. So one side should give you a higher voltage than the other. So I get 0.38 here, and the next side I get 0.4. So I get 0.38, and the next side I get 0.4. So that's working correctly. So I'm just going to remove the heatsink to take a look at the CPU die or the core. Oh, they put somebody put thermal paste on it already. All right, seems pretty good. So I'm going to plug in the power now, and I'm going to feel the PCH to see if the PCH inside of the CPU is getting warm. And it's not warm. Nope. It's not warm. All right, so it's generating 60 milliamp. All right, just checking the switch if the switch is working correctly. So it goes to 0 volts and come back, restore back to 2.4 volts, 0 volts. All right, so the switch is working. Now I need to check now to see if the EC is sending a switch signal back to the CPU. So this is the power button signal for the PCH, and also check if I'm getting RCM reset as well. So I'll need a schematic. So I'm going to see if I can get a schematic. Okay, so I've found the schematic. So first we need to check for the power button signal. Alright, so first I'm going to type in PWR-BTN, and this is the standard naming configuration for the standby name for the Intel power button. And here it is. It says called Power PWR-BTN, or you can call it, so this name is renamed to PBTN underscore out underscore hash underscore R. Alright, so I'm going to copy that. I need to find my search bar. Alright, so here is it. So I'm going to copy this signal. So this is normally coming from the EC. So we need to check if the EC is actually sending this power button signal to the PCH inside of the CPU. Alright, and as you can see, it is coming. So it's been renamed, coming through this short pad here, and it's renamed to PBT, P button, or PBTN underscore out. Alright, so I'll now search for that signal. Alright, that's the timing. That's where we're coming from. And here is it, it's coming from pin 122 of the EC. And as you can see, this is the EC, and the EC is KB9052QD. Right, and as you can see, this is a programmable EC. As you can see, the D, which is the version. So this version means that this EC is programmable, and it's a QFN. Sorry, not a QFN, it's a quad flap. A Q-sub. Alright, so we're going to check pin number 22 if we're getting 3.3 volts there. Alright, so Let me go under the microscope now. Alright, so now under the microscope. So I'm going to focus my attention here on the EC, which is pin 122. And I'm going to check here if I'm getting voltage, and I'm going to press the switch and see if the EC is actually sending this in power button signal to the CPU. Sorry about that. Alright, so on the EC here, and this is pin 122. So this is pin number 1. This is pin 100 here, 96, 97, right, 98, and 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And this is pin 122. Alright, so let me see. When I press the switch, I get 3.3 volts, as you can see. So the EC is actually sending the power button signal, right? So this is a typical no trigger fault, as you can see, because the CPU is getting the power button signal, but it's not releasing the ACPI configuration signals. So it turns on 3 volts and 5 volts. So that exit this S5. So it says, sorry, so the laptop, the motherboard is basically stuck in the S5 state, as you can see, right? So it needs to exit the S5 state into the S4 state. So I'm pressing the switch again. As you can see, I get 3.3 volts. That means that the EC has successfully sent the power button signal to the CPU. Right, so this indicates to me that the CPU is not working. So the CPU is broken. Right, so I'm getting the switch signal and it's not turning on. There's another signal I'm going to check, which is the SMC, which is a lid close signal, which is the lid cover switch signal. Right, so and that's normally we call it LID or LED underscore SW, depending on the manufacturer of the motherboard. If it's for like Apple, you have SMC underscore lid, right? If it's a Inventec, it's SMC underscore lid underscore close, right? Compa lid underscore SW. So this is the switch. This is the signal, which is a lid switch signal, which is coming to the EC at pin number 15. So I'm going to check this signal to see if it's coming high or low. This signal is active high, but when you close the lid of the laptop, it's basically low. This hashtag indicates that the signal is basically low level, a valid low signal. So I'm going to check at pin number 15 to see if I'm getting a 3.3 volt there. Alright, so I'm going to check pin number 15 for 3.3 volts high. If that 3.3 volt high is there, the lid switch is okay. So pin number 15. Pin number 15. So this is pin number 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 3.3 volts high or not? Alright, let me recount again. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And it's 0 volts. This should be high. I'm going to press the switch. Okay, and it's high. So this signal comes after pressing the switch, as you can see. Right, so this is okay. So the EC is getting the lid switch. It's actually sending the power button to the PCH and the EC and the CPU. Right, so everything is okay on the EC side. So the main problem is that the CPU, the PCH inside of the CPU, right, this is the PCH, this is the PCH, and this portion is the CPU. So the PCH inside of the CPU is not working. Right, because we get all working conditions. We have 5 volts, we have 3 volts, 1.8 volts. Right, the EC is sending the power button signal. The lid close switch is high, but therefore it's still not releasing the ACPI configuration signal. So that indicates to us that the PCH inside of the CPU is broken. All right, so another way you can confirm it is by putting this on the thermal camera to see if here is getting hot. Right, we need to see if here on the PCH, right, to see if this section is getting hot. If this is getting hot, when you press the switch, that indicates that the CPU is broken, right? This is a 10th gen CPU, all right, and I don't have the CPU for this one to replace, right? So that indicates to me that this CPU is broken, all right? So as I said before, you can try under a thermal camera, and the thermal camera can tell you exactly, once this 60 milliamp that I'm getting each time I press the button is indicating to me that the PCH is broken inside, so it's going to get hot. So that indicates that the CPU is bad, which is causing this no trigger fault. Okay? All right, so there's one more signal I need to check, which is the RSM reset signal. I forgot about that one, so I'm going to go back to the EC now and then head back to the schematic, and I will check to see if I'm getting RSM reset. Right, RSM reset signal. So I'm going to type RSM RST. Alright, so the EC will send this signal, and it's coming from, here is it, to the CPU. This is the CPU UC1K. Alright, and this is the CPU. Alright. Alright, so this is EC RSM reset, so I will copy this signal. And search. Alright, that's for discharging. PCH power OK. Alright, EC RSM reset with SLPS4. It's coming through this OR diode to become D power OK. So that means this board doesn't support the depth of sleep, because this is PCH deep sleep power OK, and EC, this signal RSM reset, right, is RSM reset, and PCH DC D power OK signal is connected to the same power rail. That indicates that this board doesn't support deep sleep. And here it is coming from pin 100 of the EC. As you can see, this is the EC, and the EC, as we know, is KB9052QD, right? And it's coming from pin 100. So I'm going to check pin 100 under the microscope. Right. Alright, so pin 100. This is the final signal, and if the signal is coming, then the CPU is definitely broken. Alright, so pin 100 is right here. Alright, so this is pin 96, 97, 98, 99, 100. Alright, so I'm going to press the switch, and we get RSM reset. RSM reset is okay, everything is okay, the PCH is faulty, as you can see. So I don't have a CPU. Right, so I don't have a CPU to replace on this board. This is a 10th gen CPU, so I will just give it back to the repair guy. The CPU is expensive, so I will just return it back, because the CPU is basically worth more than the price that's normally I would charge to repair. So it doesn't make any sense, it's not worth it. Alright, so I will just give it back to him. And this is the process that you should take, or we normally take, to troubleshoot a no trigger fault. Right, and as you can see, the CPU is broken. So I hope you enjoyed the video. I hope you learned something, and in the next video I'm going to see if I can fix something for you. All right, bye.